All right, lesson 12.5. Last section in 12.4 we talked about probability, the likeliness of an event to happen from 0 to 100% or 0 to 1. Now we're going to actually do some calculations after experiments, so to speak, have been conducted. So experimental probability is the ratio, fraction, of a number of times an event occurs divided by the total number of trials. Okay, so, and this gives us a little formula. Number of times an event occurs divided by the total number of trials. Okay, and we're going to actually get right to it. This is an actual calculation. So Tanya made saves on 15 out of 25 shots. What is the experimental probability she will make a save on the next shot? Express your answer as a fraction, a decimal, as a percentage. So in this case, Tanya is some sort of a goalkeeper. It sounds like anyway. Maybe hockey, field hockey, soccer, something like that. And so she made stops on 15 out of 25 shot attempts. And so we are going to calculate the percentage, assuming that these, and again, these percentages give us the likelihood of an event to occur in the future based on past experience. So we're going to take the number of times an event happens, and in this case, that's the number of saves, 15, out of the total number of trials, which is 25. Okay, so express your answer as a fraction, decimal, or percentage. Well, I'm going to go ahead, in this case, I'm going to reduce this to lowest terms. We know that both of these divide by 5, so 3, and divide by 5, 4. So we have a 3 out of 4 chance, 3/4 chance that she will save. So she's saving 3 out of every 4 shots. Okay. As a decimal, 3 divided by 4 is 0.75. As a percentage, obviously the decimal goes 2 paces to the right, 75. I don't like that. I'm going to change it so that it looks legible. 75%. So there's a 75% chance that she will save the next shot. Again, assuming that events transpired like they had. Okay, obviously things could happen that change it, but based on past experience, she should save 3 out of 4 shots. Weather application. For the past 3 weeks, Carl has been recording the daily high temperatures for a science project. Here are his results. So week 1, week 2, and week 3 in tables below here. What is the experimental probability that the temperature will be above 75 degrees on the next day? Okay? And so remember, again, probability is the times the event occurs over the total number of trials. So I'm going to go ahead through here, and I'm going to highlight, first of all, everything that is above 75 degrees. So this will work, good, good, good. No, not marking 75. Again, we are going above 75 in this case. So equal to does not work in this particular calculation. All right, so there we are. Okay, so the number of times that we are above 75 degrees are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. And in 3 weeks is 21 days. Now if you want to reduce your fraction, these both divide by 7. And so we have 2/3. Now, and 2/3 is fine for a probability, 2 out of 3. If you want a percentage, this is approximately, I'm going to go approximately 0.6 repeating. Well, actually, it's exactly 0.6 repeating, which is approximately 67. You know what? I'll go 66.6 repeating percent. Okay, now we were not asked in this particular case to go to a decimal or a percentage, but I'll just do it for the sake of a little extra added bonus. All right, what is the, so same information, okay. What is the experimental probability the temperature will not be above 75%? Now, the one thing you can do is you can go back through and highlight all of the ones that were not. or that are not above 75%, or 75, I keep saying percent, degrees. But the other part of this is if I flip back to the previous slide, we already know which ones are. We know that 14 out of 21 are. So if we take the complement, that would be the ones that are not. That would leave me 7, right? So 7 out of 21. All right. So, and if we divide by 7, this is 1/3. So in this case, if we just go with the complement, this would be 0.3 repeating as a decimal, which is, and I was going to do, I'll go ahead and use the exact, which would be 33.3 repeating percent. Okay, so in this case, knowing the complement, the things that are not from the previous slide, we actually don't have to go do the counting again. But if you want to, you can go through and do the counting again if you really feel the need. So, all right, that gets you to the end. Okay, again, when we do experimental probability, the number of times that an event actually occurs divided by the total, and then express our answer in whatever format we're asked to express it in. So, all right, come see me for help. Good luck.